So thanks for coming today. It's good to be here. My name is Matthew Skelton.
And I'm 𝗦𝗃𝗶𝗆.
We're here today to share with you some ideas and thinking and experience on team cognitive load as a lens to look at the size of software systems that we should be building. So today's talk looks like this. We'll talk a little bit about monoliths and microservices. Then we'll look at what we mean by team cognitive load. Manuel will share some case studies. And finally, we'll look at ways to get started with this kind of approach. We are authors of a book called Team Topologies, which was published in September this year by IT Revolution Press, home of Accelerate, and the kind of sibling publication of 𝗦𝗃𝗂𝗍𝗆's book, Project to Product, which we heard about this morning. And there's a book signing today, courtesy of 𝗕𝗵𝗍𝗶𝘀𝗶𝘆. So at 4 o'clock, 1600 hours, at the 𝗕𝗵𝗍𝗶𝘆 stand, come and get your book signed by me and Manuel. So thank you, 𝗕𝗵𝗍𝗶𝘆, for doing that. So we hear a lot about monoliths and microservices in the context of modern software development. But it sometimes seems like a bit of a fight. So, in one corner we've got 𝗘𝗵𝗍𝗶𝘆 saying, start with monolith and extract microservices. And then the other corner we've got 𝗦𝗃𝗁𝗃𝗃𝗃, who says, don't start with a monolith when your goal is a microservices architecture. What's going on here? Two very experienced people coming up with very different approaches to building software systems. And then the wise sage Simon Brown says, if you can't build a monolith, what makes you think microservices are the answer? We need a different way of looking at this kind of this pattern. So where should we focus, right? And I think that 𝗦𝗃𝗂𝗍𝗆, who will be speaking later on today, so Daniel puts it very well when he says, we need to think about software that fits in your head. So he's very much thinking about the needs of the individual in terms of understanding the software systems when we're writing code, when we're working with testing it, or when we're deploying it or operating it. In the context of teams, which is where we know we need to be focusing in 2019 and beyond, we can kind of change that phrase slightly to say software that fits in our heads as a team. Let's take a couple of minutes to think about the 4 key metrics from the book Accelerate. Who has not yet read their copy of Accelerate book? Everyone's got a copy, right? Good. If you haven't, there we go. There's one. Oh, there's one here, literally in the room. So there's these 4 key metrics that indicate high-performing organizations. One is lead time. We've got deployment frequency, mean time to restore, and change fail percentage. So the key thing here is, if you think about it, every one of these 4 metrics will be difficult to improve if we're working with software that does not fit in our heads. Lead time between, say, code commit and working in production. If the software is too big for us to think about, there's a danger that we'll add in extra testing steps or we'll miss something. There's a danger that lead time starts to extend. There's a danger as well that deployment frequency goes down, so we deploy less often if the size of the software we're working on is too large. It will take us longer to restore service in production after a failure. Again, if the software is too kind of awkward to fit in our heads, too large to fit in our heads. And the same with change fail percentage. The number of times that a software release to production goes wrong is likely to increase. Again, if we look at these kind of metrics through the lens of software that fits in our heads as a team, what we've seen is that this is a useful way of approaching this kind of socio-technical problem, which is software development, modern software development. Ultimately, so here's the slide that you can look at and take a picture of. If you want to go to sleep for the rest of the talk, that's fine. This is the key message. Software that's too big for our heads works against organizational agility. So we're explicitly saying, let's think about the humans involved who are building the software. Let's think about the kind of dynamics and the relationship of those humans to the software that they're working on, and do something about it. Don't just ignore that. Lots of organizations have ignored the size of software that they give to a team to work on, with kind of predictably bad results. So let's talk a little bit about team cognitive load, because this is the kind of concept which helps to frame this way of thinking. Cognitive load was defined by Australian psychologist John Sweller in 1988 as the total amount of mental effort being used in the working memory. In the context of software development, building systems, working with kind of user requirements, testing, operating, and so on, then we're using a lot of mental effort. These kind of tasks create a kind of cognitive demand on people who are working in this space. It's not primarily a physical activity, is what I'm saying. It's substantially a mental activity. So cognitive load comes into play. There are three kinds of cognitive load: intrinsic, extraneous, and germane. Intrinsic is kind of the fundamental stuff about the kind of skills we need in order to work in this space. So if we're thinking about software development, it could be, how do we define classes in Java? This is kind of a fairly fundamental intrinsic thing. We just need to have it in the background. It could be, how does a CPU work, or how does networking work? Something that's really fundamental to building software. Extraneous cognitive load is things that get in the way, things that we really shouldn't need to think about in order to do the task that we're working on. So if we have to think, how do I deploy this application again on this platform? What config settings do I have to make? That's kind of extraneous. It's getting in the way of doing useful things. Whereas germane is the cognitive load that I want to be able to think about, I need to think about, because that's key to delivering useful value. So if we're working on a financial, perhaps a payment application or something, mobile application, I need to understand how bank transfers actually work, because that's really important for me when I'm building a new feature that deals with bank transfers. So I want to fundamentally make sure that I've got as much space for germane cognitive load as possible. So to visualize that, it looks something like this. We've got to deal with the intrinsic stuff. We want to squeeze down and minimize the extraneous cognitive load to leave plenty of space for the germane. So this is effectively a focus on business value, if you like, in the germane space. That's what we're really talking about here. So we're looking at it through the lens of kind of cognitive load for individuals and for a team. If you want to know more about all this stuff, by the way, there are some great talks by 𝗘𝗵𝗋𝗆. If you search for hacking your head, you'll find some talks from a couple of years ago and a whole lot of slides and things. We were really inspired by the way that Joe describes cognitive load here. What this means then, if we take this on board, is that we should limit the size of software services or products to the cognitive load that the team can handle. So we're explicitly limiting the size of our software, explicitly architecting effectively our software to match the cognitive load of teams. This is a very different way of thinking about software architecture compared to how we've done it in the past. But this is increasingly important if we're going to have a sustainable approach to software delivery that has an emphasis on flow. As we heard this morning from 𝗦𝗃𝗃𝗍𝗏, the implications of flow are that we've actually got to change the way we think about all sorts of things, and this is one of them. So we end up building software that fits in our heads, like 𝗦𝗃𝗃𝗍𝗏 said. So this kind of is very much a team-first approach to software boundaries. We're not starting with technology, we're starting with the team, and we're inferring what the shape of the software system should look like based on the kind of properties, if you like, of the team that's building the software. When we say team, we mean a kind of stable unit of people that's probably less than 9 people. In some organizations with very high trust, you might get away with a group of people up to about 15. But if you think about sports teams, you very rarely see a sports team that's actually bigger than 15. There are reasons for that, kind of evolutionary reasons for why that's the case. It relates to trust boundaries. But in most organizations, you'd expect a software team actually to be no more than about 9 people in size. That's where you kind of got the right balance of kind of close trust within the team to be able to be a high-performing group. And it's really important that each service should be fully owned by a team with sufficient cognitive capacity to build and operate it. So we're not handing it off to another team. We don't just take a slice of something and we don't share it with another group. So this model has proven to scale very well. So Amazon began to use models that were effectively like this back in 2003, and clearly Amazon has not suffered a scaling challenge since 2003 by operating these kind of 2 pizza teams. This works very well, it really does scale. We need to apply whole team techniques, things like mobbing, where we've got the entire team around a single keyboard and monitor, all focused on the same problem at the same time. We minimize bugs, we get flow much quicker. We're not splitting up the work into multiple individuals inside a single team. We've got a team-focused approach to how we actually do the work. We use techniques like domain-driven design, DDD, to help us choose good domain boundaries. That relates to where we split different bits of the software and assign it to different teams. So the DDD techniques have been around many years, and now we're able to start applying them. We've got there's many more kind of examples and understanding of how these techniques can be used to help us do that. So that helps us to kind of align different parts of the different teams to different kind of slices of business value, effectively, to align to the flow of change. We need to focus on developer experience, or more generally kind of engineer experience. So what does it feel like to work with the software we're working with? What does it feel like to work with the platform that we're using? What does it feel like to work in this organization as a whole? We also need to make sure the operator experience is addressed, so that it's not just about people who are building the software, but people who are on call, people who are running this software in production. What's their experience of working with the software? So a focus on operability is really key. We need a platform. You will have a platform in your organization, whether you like it or not. Even if you're a tiny startup and you only use a few Amazon services, that's your platform. 5 Amazon services, by definition, that is kind of the platform that you're using. We don't want to go ahead and build a massive, hulking, great platform like we did in the kind of 1990s, 2000s. We're talking about something that's the thinnest platform possible, so thinnest viable platform as a concept. But we need to define it. We need to understand what's in there. The reason we do that is we're trying to push extraneous cognitive load down into the platform, so that people developing applications don't need to think about a whole load of stuff. It's there in the platform. So in our book, we talk about 4 fundamental topologies, team topologies that we believe are needed to make this stuff work. We've tried to find a 5th or a 6th that's actually necessary. We can't find it yet. We're not convinced that there's a need for any more. And in fact, in this model, really, there's only one that's necessary. And the one that's really necessary is the one at the top, the stream-aligned team. A team that's aligned to a flow of change, as identified by 𝗦𝗃𝗃𝗍𝗆 in this morning. We've got to understand what the important flows of business value are in the organization, so we align teams to those flows. The other 3 types of team are primarily there to reduce the cognitive load on the stream-aligned team. That's a really important way of looking at the relationship between teams and the purpose of teams. It's about reducing the cognitive load on streamlined teams to allow those teams to focus on the germane aspects of their business domain. So if we have a flow of change from left to right, we've got, in this diagram, we've got 3 stream-aligned teams. So we've got 3 different things that these teams are working on. There's a platform underneath in blue. On the left-hand side, there is a little complicated subsystem. Perhaps it's some video processing thing or some kind of transaction handling that's really awkward, and so it needs some specialists in there. But only 2 of the teams are using that. And we've also, at the right-hand side in green, we've got a team that acts in an enabling way with 2 of the teams, perhaps to help them migrate from one cloud to another, or perhaps to help them to get to grips with something like machine learning or something like this. So the kind of teams are different depending on what we're trying to achieve. We don't just have a single kind of team across the organization. And the kind of interactions are different because, for example, the complicated subsystem in red at the left, they just provide that effectively like as a service. They create a nice API, a nice interface around it, and the other two teams, the Streamline teams, can just consume that without very much interaction at all. However, the Streamline team at the bottom is collaborating with the platform at this point in time. They're collaborating with the platform on some new metrics or logging or something. And so the way in which they interact with the platform is different from the way in which the other two teams interact. The two teams at the top are being facilitated by the kind of enabling team. Again, that interaction is also different. They're not providing a service. The feeling is different. If they feel like they're being facilitated, they're being helped, they're being facilitated by some people in the enabling team. The key thing here is different kind of teams and different kind of team interactions, and we're being very explicit about what those team types are and what those interactions are or should be. And this is just a snapshot in time. This starts to move towards something called environmental scanning, which Dr. 𝗦𝗫𝗂𝗍𝗏 describes in one of her books. So she's one of the foremost authors in organization design in the world. And this is really important. It enables the organization to be able to start thinking about its own internal environment and the external environment as well. We'll now hear some case studies from Manuel.
Thank you, Matthew. So let's look at a couple of case studies around these ideas of sizing the software according to the teams, but not only just the software itself, but in general the responsibilities of teams. So one case study is from a large retailer worldwide. So they're pretty big, but they're still growing and reaching new markets. But they're really kind of at the enterprise stage. So back in 2016, they are aware that delivery is pretty slow, and any innovation is taking quite long to actually reach the customers. So they said, okay, we want to enter a new market, and we want to have a really high-level mobile experience. So they said, let's do things differently, and they set up a cross-functional team with autonomy, and they said, you can use all the practices that you find necessary. So they, all the good stuff around DevOps, continuous delivery, using public cloud, etc. And this worked quite well. So they actually delivered the first version of the mobile app earlier than expected. So this was kind of totally new for this enterprise, that something was ahead of schedule. And they iterated and they improved over time. So it was like a really good success story, something good to share in a presentation like this. So obviously what happened next was that they were asked to do the same for another market. And that was fine. They added a couple of people, and they started having a little more complexity in the back end. So they needed a CMS to actually manage changes to different markets. And this went on again and again, right? So the success of this team was kind of leading to doing more and more. So they were now doing different markets and mobile experience, and you can see the back end is getting a bit more complicated. And so they need a product catalog, and they need kind of framework with some common services to the different mobile sites. But perhaps more importantly, you can see the team is growing, and as the software is growing as well. But what happened at this point, and this was noticed especially by a couple of senior architects in the team, was that it felt like they were delivering much slower than they did, a year or a year and a half before. So they started having actually different streams of work within the team and that were blocking each other. And they started having people specialized in certain parts of the system, because basically it was too large as a whole for everyone to be able to understand the entire system and actually, like Matthew was mentioning before, in terms of building, operating this, all the parts that they were responsible in an effective way. So it started having kind of sub-teams essentially. So against actually the will of the team, because they were actually, they knew each other pretty well, they liked working with each other, but they felt there was this problem. So they decided to split up into two smaller teams. There was some resistance, but eventually they did this. And so you see the team on the right is more focused kind of on the front end part and product catalog, and the other team is focused more on the back end. So what they did was essentially able to kind of split up along different work streams, and they were now able to work much more independently. So each team, let's say 70% of the time, 80% of the time, can work on their own roadmap without depending on the other team. But there are dependencies, obviously. It's still a single system, if you like. So they explicitly, and that's depicted by the two bars between the teams, they explicitly expected, okay, we need strong communication and expect to invest effort and time to allow for synchronization between the two teams. So on a regular basis, they get together, they understand, what's your roadmap, what are we doing, what are the dependencies, and where do we need to sync, and perhaps people need to pair, people from the two teams need to pair for a period of time to actually deliver quickly and with the right approach and define the right APIs, etc. So this worked quite well for them. So they continued on this path, and I believe today they are mostly having even smaller teams aligned to different markets, so they can go as fast as possible, adapting to the specificities of each market. And on the back end, they've also split further. So this worked quite well for them. Essentially, they were aware that the team is becoming too large. It's getting harder to communicate efficiently within the team. And the system as well was becoming a little bit monolithic and hard to change. So they were listening to these triggers of, we need to evolve, we need to find a better way. So software is too big. They had people over-specializing. So Brent is a character in the Phoenix Project book. I don't know if people have read it. So he's like the bottleneck. He's the only person who knows how to do certain things. So when you have many teams depending on that, then you have a scheduling problem, prioritization problem. And overall, just more need to coordinate. The second case study is slightly different from a company called OutSystems. They are a low-code platform vendor. They've been quite successful in the last years. And this team is called the Engineering Productivity Team at OutSystems. So they exist to help the other engineering teams, the product-focused teams, do their work more efficiently, reduce cognitive load. And what happened was that over time, this team kept growing as well, and they took on more responsibility. So I think they started with test automation and build and CI support for those engineering teams. And then, they were successful, and they were asked to do more things, continuous delivery enablement, automating the infrastructure. And because of their success, again, they were being asked more and more specific things from the engineering teams. What happened here was, again, that there was too much cognitive load for any one person in this team to understand all the different domains, these 4 kind of large domains. So essentially, you had people that were not engaged anymore with the team meetings and the sprint plannings and so on, because perhaps 20% of that time was something related to their domain, and the rest of the time was just they were there, waiting for the meeting to be over. So it's essentially too much cognitive load to be responsible for these 4 domains, and people had to specialize at 1 or 2 at most. So in a similar way, they decided to split up into smaller teams. So each team is now aligned to a single domain. And the other change they made is each of these teams is flat. There's no team lead. So everyone inside the small team has the same kind of level. And what they told us that immediately they saw the effects. So if you think back about the intrinsic motivators that the book Drive talks about, is autonomy, mastery, and purpose. So each of these teams was in a much better place to achieve that. So people felt like, okay, now I have the power to decide what I really should work on for this domain. Instead of just firefighting and kind of trying to keep up with the requests from all the product teams, they were having the effort available also to improve their knowledge of the domains and sort out what really can help us be more effective as an organization. And then you can see there are communication lines between these teams. Obviously, there are issues and requests that are cross-cutting. So what they do in that case is sometimes set up a kind of micro team with one person from each domain that's involved. And they work together for a specified period of time. And then they go back to their original teams and bring back kind of the knowledge that's specific to their domain. So this worked quite well for them. And the irony here is that this original kind of large team was trying to reduce cognitive load, but they themselves fell prey to too much cognitive load demand on them. So just remember, it's not always just about software size, because many teams have responsibilities and they provide support and they're not necessarily developing a ton of software. Just align the size and number of domains of responsibility with cognitive capacity. And this pattern worked quite well to have perhaps smaller teams with high cohesion, where people have these shared values and purpose. That's super important. And then between different teams, you expect to be as decoupled as possible. There will be times where you need to synchronize, but you should expect that to need lower bandwidth communication between smaller teams. So again, it's very important to align the software and responsibilities to the teams and make sure that each one has a very clear ownership. And the triggers for kind of evolution in this case were around these awkward interactions inside the team, actually. And some people were not engaged. Some were at the point of leaving the organization because they were basically burned out from all this stress of having to, or supposedly having to understand all these different domains. And just in the day-to-day work, this all frequent context switching and running around trying to kind of fix requests and problems without kind of a sense of purpose and kind of what are we trying to achieve, and what have we had the time to think about this and invest properly. Give it back to you, Matthew.
So we're close to the end of the session. So I'm going to give you just a couple of pointers, things that you can try inside your organization to start experimenting with some of these approaches. Try and just assess how well people on the team really understand the systems that they work on. So just ask them a question. Just do a survey monkey or something like score of 1 to 5. How anxious are you about the systems that you work on, for example? Just as an initial assessment. Because if you get some responses from one particular area where the whole team or most people on the team are actually pretty anxious about the software that they work on, really not happy, they don't really understand it, that's a leading indicator for future problems. Because it's almost certain we're going to get some deployment failures or we're going to get some bugs in production from that around that system. And we need to be looking at leading indicators where we can. What would change in your organization if you adopted these 3 explicit team interaction modes, where the only ways in which teams actually interact are either through collaboration, working together, X as a service, where one team is providing or another team is consuming something, an API, a library, whatever, or a facilitating interaction, where one team is being helped by another team. What would happen if you kind of clarified the team interactions inside your organization? What is your platform that you currently run on? How well is it defined? If, like we said, if you're a startup and you're only using 5 Amazon services, put it in a wiki page. Define that it's those 5 services that you're using, that's your platform. Your platform can literally be the definitions of some services in a wiki page. It doesn't need to be anything bigger than that. That's why it's thinnest viable. The key thing there is define it. Make it clear to people how they use that platform, which things they should use, which things they shouldn't use, and then start to think about the kind of onboarding experience for new engineers inside the organization. How easy is it for them to understand how to get started with this way of working, using the tools and so on in your platform? You'll be surprised how much value you can get from better defining what you already have. And you'll be surprised how many gaps there are and how much misunderstanding there is about what the platform currently is, unless you've got some nice documentation already. So if you're interested in this stuff, come to the ZB Lab stand at 4 o'clock today, 1600 hours, where we'll be signing the book. Or you can go online, teamtopologies.com/book, and buy a copy. We do offer some training as well. Come and speak to us. The easiest, well, you can see I'm wearing a fairly bright jumper. Manuel's over there. At the very least, you'll meet us at the ZB Lab stand at 4 o'clock. We are looking for some case studies. We're working with a few companies, a global manufacturing company, a large government agency, and some financial services companies to start to put into practice some of these patterns. If you're interested, come and speak to us, and we're putting some kind of industry examples online. And we've got a newsletter, so sign up at teamtopologies.com. Thank you very much.